Okay. So those who are like, there are a couple of students joined today. This is the first class, but don't for them, this is the first class. So if anybody want any kind of refresher, please let me know. This is going to be getting more and more. We are getting more into machine learning. So the first class session we had mostly was, we talk about what is machine learning, and we talk about a lot of basics. We talk about what is artificial intelligence, machine learning, what is deep learning, data science. And then we also talk a little bit about what, more detail into machine learning, what all different machine learning, approaches, 3 different approaches we talk about it. And also we kind of go through different real life example of how the machine learning works. So I just wanted to give a very high level overview what we covered, but I'm going to keep an office hour on Thursday evening. India, it will be morning time, and I will send that time so that I can catch up with all the things we covered in the first week. This is for those who joined late, so that they can catch up with all the things we covered. So I just wanted to give you a very high level, and then we are going to start with today's class. So machine learning, we have 3 different approaches. One is supervised, second one is unsupervised, and third one is reinforcement learning. And today's classes, we are going to deep dive into supervised learning, and we are going to work on a project, and we are going to work together. And if you want, you can do it, or just follow what I am doing. And after the class, you can try yourself. But I'm going to explain each and every step, what it is, and then how we are approaching the supervised learning and things like that. So today's class is more about that. That is a scope. And I know most of you have already installed Jupyter notebook. And if not, please, send me an email or in the chat. I will work with you on Thursday to get that completed. Okay. So today we are working on supervised learning, and under supervised learning, we have, today's class is more related to regression. So let me get started for today's class. Those who are new, don't worry, we will catch up. But try to understand what I'm trying to, explain, but it will give you some idea, okay? Okay, so welcome today's class, and today's class is supervised learning. So all you know what a supervised learning is, you have, when it will be a supervised learning means, the outcome, right? What you're going to predict it, you kind of name it a label that, I am trying to predict it, and this is the outcome, a labeled outcome, and that becomes a supervised learning. So labeled output means you have a data set, and I can give you an example of a data set we are going to work today. Is opening the file. So we have a data set, like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 columns. And the first 13 columns are the input, and the 14th column is the one we are trying to predict it. These are the columns related to a housing market, the data, and we are predicting the price of the house. So that is what we are trying to do. But so this is your label. This is the label, and these are the features. But I'll explain it more in detail. I just wanted to give you what a data set is. A data set we have around 516 rows. And this is what we are going to teach our model so that we can get the prediction. Okay. So I'm going to go through a little bit more in detail. I just wanted to give you an understanding that supervised learning, we have a labeled data, and we are trying to predict it. So one more thing I wanted to make sure that you all have access to Google Classroom. Let me know if you don't. I can, if anybody has, don't know where the Google Classroom is, please let me know. Let me go to Google Classroom and I will show you what we have here. Okay, let me go to the Google Classroom and let you know what it is. Classroom.google.com, where all your work will be posted here. Every week we will have whatever video will be posted. This class video will be posted, and I posted a data set here. It's called housing.csv, and this is what we are going to work with. So just have your housing.csv downloaded into your machine, into your laptop. So just keep it with you. So when we start it, you will start working on that. All right. So now, now we are going to go back and continue with the supervised learning we are going to cover. So supervised learning, there are two different types. One, if the target value, so target value is what we are going to predict it. And that value, for example, in this data set, we were kind of looking at the housing market. We have the crime rate, that is one of the data we got. And then the proportion of residential land zoned lots over 25,000 square feet. And there are so many different features. And then the last one is more important. This median value of owner occupied homes. This is what we are trying to predict it. And the rest of the third. So we have 13 category, fields. And the last one is the prediction. So MEDV is the column which we are trying to predict it. But we have 506 records with all those information and the value which we really calculated, the medieval value range we calculated. And this is what we are going to teach the model so that the model can predict it in the future, right? So in this supervised learning, we have two different target variables. So target variable, an example here is medieval, MEDV, a median value of owner. That's what we are trying to predict it, okay? If the target value is a continuous number, or let's say, for example, blood pressure, it's 80, 120, height, 5 feet or 5 feet 5 inches, 5 feet 6 inches, like that. Weight, you have 120 pounds or 50 kilograms, and things like that. And income is a number, age is a number. So this is called a continuous target variable. And we use regression for, because we have different methods of selecting the algorithm for the model. So we are going to do regression, and we are going to study today about regression. This is what we are going to study today. And the other type of model is a it's called the target variable, which is a categorical. So for example, categorical means a race can be Asian, American, and Middle East, those kind of categorical values, right? Those are the fixed values: sex, male, female, age, between middle age or different age group, which is a constant value, age group. And educational level, are you, undergraduate or graduate, those are different levels. So those are kind of like a categorical target value. We use classification for that. So for example, medical imaging is one example where we take a picture of a cell and see whether we predict whether it's a cancerous cell or a non-cancerous cell. So that is the, so supervised learning, just understand one thing. Supervised learning need a target variable, but this target variable, if it is continuous, we use regression. If the target variable is categorical, we use classification. So today's class, we are going to work on regression. So example I given. So today we are going to do a project on housing, housing price prediction. So that's what we are going to do today. So I just wanted to give an understanding. So just want to give you a very high level and say machine learning types. So machine learning types, we already saw supervised, unsupervised, semi-supervised, or reinforcement. We are covering today under supervised, continuous target variable, and regression. So that is what we are going to cover. So sit tight and understand the concept. So this is a very high level. So what we are going to cover. And these are the different algorithms in supervised learning. Some of them are linear regression is more for continuous, logistic for categorical. So we will cover a little bit more. I just want to give you an understanding before we jump in and go in detail. So here is the project. Are you guys following me? Please chat. You can hear me. Okay. How can you download? One question. How can you download the housing file? So go to Google Classroom and just go to Google Classroom, and the first one you see is, let me go back to show what I'm talking about. In the Google Classroom, you will see, okay, here. So week 3 exploratory data analysis, you click this and then you can download from here. This file you can download. So click view material and then from there you can download. And otherwise I will send out an email with this file to everyone. So let me do that. Send. I'm going to send the email right now. If you have difficulty. It's called housing. It's Dataset. Okay? This is called housing.csv. I just send it in email. So just download and keep it ready. Okay. So in this data set, we have 14 columns. 13 of them are the predictive, and the last one it's a numerical value, and the last one is the target, which is a median value. So total 14. So this is what we have. So all those things with all the value we collected, and the last one, MEDV, median value, is what we are trying to predict it. But before predicting, we need to teach the model that, hey, these are all the things. It's like it is like learning. You are preparing for the exam, but you learn everything. And when you go to the exam, you start writing the answer, like whatever you learn. So we have been given 506 records to teach the model. So just imagine that it is like you are in the class learning, but once the teaching is done, you are going to start predicting it. So just when I was learning machine learning, I had the same question, that why they are giving the target value, because target value is something which you kind of learn or teach the model, so that next time Next time when the exam comes, you will give all the 13 things, but then you have to predict it. That's the end goal, right? Okay. So I already sent you the data set, and then we are going to kind of little bit more in understand the basics of some of the statistical methods. So some of the method I want to make sure you understand that mean is just a number which is an average number. So let's say in this example, 4, 9, 11, 12, 17, 5, 8, 12, 14, we have given 9 different numbers. And what is the mean? So what is the mean means? With all these number, what is the mean? The mean is the average of 4 plus 9 plus 11 plus 12 plus 17 plus 5 plus 8 plus 12 plus 14 divided by 9. That's the mean. Just imagine. I think you must have learned in school what mean is, right? So, but I wanted to make you aware of what is the standard deviation. So as part of the, before even jumping into working on this supervised learning, we need to understand the data given to you, right? So basically, you go through the data, make sure that what we are trying to predict it, is that really relevant for that? So let's say you are learning math, and you are going to give an exam end of the year. You have a final exam. So you've been supplied 100 different books. Out of this 100 books, a lot of these books are not even relevant for your studies or syllabus. So what do? You just avoid those books, and you will only select the 10 books which are really matter for those exam, right? So what is the reason for reading through all the 100 books, right? It is going to be taking a lot of time. And out of this 900 books, the 90 books is not even going to your whatever exam you're going to give. It is not even going to come in the exam. So what you will do, you will first remove all the 90 books, keep the 10 books in your interest for teaching, right? So like that, here we got for 13 different columns, like a crime rate, population index. Out of this 13 columns, which one is really related to the pricing? So out of 13, we may eliminate 11 of them. So only 2 columns are really related to the pricing of the house. Just like that, what I give you an example, you've been given 100 books, you just eliminate 90 of them, or just learn that 10 books which is really for your exam, right? That is what we are really doing, called exploratory data analysis. So what we do is we look at the data using the statistical method. You eliminate some of these features which is not being related to the outcome or predicted value, right? So that is, for example, in this, house prediction, if there is a column which says this person who, the house which is there has some feature which is not related to the price at all, do you really want that to learn for the model? No. For example, this house, we got what I call, there is a couple of sofas, like 3 sofas in the house. Because when you're selling the house, will that matter? The number of sofas? No, doesn't matter, right? So this is a very bad example, but I just wanted to give you, like, how we can eliminate the features which is not related or correlated with your target value. So the medium value of the owner occupied home is what we are trying to predict it. But if there, in this 13 columns, some of them are not even related, so we can just avoid it. So that is what we are going to do right now with the first exploratory. So that is where we need to learn about mean and standard deviation minimum. Those things you need to know. So here is an example of a mean. I said we have given 9 different values, and 10.22 is the medium or the average value. So a standard deviation is nothing, but if you are deducting the value for for minus the average. So for example, here 4 minus 10.22 is minus 6.22. 9 minus 10.22 is minus 1.22, right? So like that, we have we calculate the deviation. So how the data is deviated from the average. So that's what the average. So in school also, when you get the exam result, what is, you may be thinking, what is the average mark, right? And then based on that, teacher may give some extra credits and to make up. If the average is too less, then teacher will give you some extra way to make up, right, the mark. So just an example. But when you find the difference between the the column, the value, and the mean, you just square it, because there is a lot of minus, because what we are looking at, whether it is minus or plus, but we just wanted to square. Square means when you square it, the negative will go, because negative multiplied by negative is a positive. So here it is 38.72, 1.49, 0.1, 0.60. So this is what the sum, and then you sum up all those squared value, the deviated value, and here in this example is 139.56. And then you are dividing that by the count, taking the average, which is 15.51, because we already square root, right? Squared it. So, and find the square root, which is 3.94. So here in this example, the standard deviation of this problem is 3.94. The standard deviation is 3.94, right? So just understand, a mean is basically an average of the numbers, but the standard deviation is a difference between the value and the mean, and you square it, find the average of that, and then you take the square root, and that's how the standard deviation. So standard deviation is very, very important, because when you look at the data, if the standard deviation value is near to 0, that means the data is really well, formed data. So that means, it is near to the average. It is going in a very good shape. The data is good. But if the standard deviation is too high, that means there is a lot of noise. We call it as noise in the data. So there are some data which you get it, which is not even relevant. So you just take that out, right? Because that particular column may not be of any use, like that attribute or that feature may not be that use. So let's say out of 100 books, you come to 10 books you're studying, and out of the 10 book, one book, you go through the book and it is giving all wrong answers. And somebody published a book with all these wrong answers, and some of them are not really relevant to what you are trying to learn. So what you will do, you will eliminate that, right? So that is what we are using the standard deviation to find whether this feature is good or not. So this is part of the exploratory analysis. So as a data scientist, when you have been given a problem, the first thing is what you do is you get your data set and find whether this data set out of this columns, whether this data is really, is it a good data or not? So it's like reading through the book and just understand this book is good or bad, right? So that is what we already covered. Mean, we covered data standard deviation. And these are the basic. That's what I wanted to make sure you understand that. It's pretty easy, right? You just understand that and then go with it. These words doesn't confuse you that much. So a low value of standard deviation means it's close to the cluster, which is which is really near to that average. So that's what it is I was talking about. A high value of standard deviation means the data is dispersed. So there is a lot of noise in the data, right? So now we also want to learn about percentile. So what is the 25 percentile, that 50 percentile, 75 percentile, and max? And when you're giving any exams like a SAT exam here in US and India, there is another entrance exams. So different exams, you always see, oh, you are 90th percentile, 99 percentile. So how do you calculate those percentile is, so for example, what is a 25 percentile means? So you have given a data 73, 58, 67, 93, 33, 18, 147. And you can see it's not even sorted, right? So let's first sort this data like 18, 33, 58, 67, 73, 93, and 147. We sort this data. And then, so how many observations are there? We have 7 observations, 7 information has been given. So what you do, there is a simple formula, and you look at 25% of 7 plus 1, which is the total number of, observation here, 7. So 7 plus 1, 8. 8 multiplied by 25% is going to be what? It is going to be the second observation, which is 33 is the 25%, right? And this will give you a lot of, when I go through the data exploration, and this is going to be really helping. So as soon as you get your exam, you got your question paper, you just look at the first topic and then second question and just see, oh, how does it look? This is good, right? So you are ready for the exam, right? So, or you go for previous question paper and then go through the questions and see, oh, this is coming, and these exams are related to my whatever I'm studying. So this is a 25 percentile, which is 58 is the 25th percentile, and 50th percentile is the same logic applied. 50% of 7 plus 1, and what will get? 4th observation. So the sorted file, you have the 4th observation is 67, and the 75th percentile is the 6th, and then the maximum is 147. So if you know 1, 2, 3, 4, 5, 6, you are kind of really little bit mastered your statistics method for your age. If it is school, but college, we have more things to do. But just understand mean, standard deviation, percentile. That's very important for data exploration. Okay. I just give you an example of a standard deviation. This kind of formula may freak you out, but I showed you how to calculate this in the Excel. But that's very simple words. If you've been given a paper and a pen and then try to find a standard deviation, you can easily do it. Okay, good. Okay. Now we are going to go into the project. So consider that you all data scientists, and you've been recruited as an employee, and then you've been given a problem, right? So it's like, you're giving a project, and this is what the project will say. Okay, that's a title, the predicting Boston house prices with regression. They won't say with regression, but for our class I put it here. So this project is, the scope of this project is, the house prices, the prediction of house prices, and given the explanatory variables, which is the 13 variables we have been given that cover many aspects of our residential houses in Boston, the place in Boston. So what they did is they went to look at each actual data, go through each house, and collected all these surveys, like, what is the crime rate in that area, what is the proportional zone, and different variables, how many rooms are available, and like that. Based on that, hey, this is the real price. So we got 13 columns, and then the final price is also given for teaching purpose. Okay. All right. So we already saw the problem statement. We are going to implement a model for predicting the house pricing using some of the regression techniques based on some features in the data set. So in the end, what it does is you are kind of creating a model, a machine learning model program, where you are going to teach the model, the computer, to, hey, these are the features and this is the price, right? And then that's what our, and then finally the end result is you are being given to predict the price of the house, right? So this is one example that the same thing applied for loan application, right? People are applying for loan, and looking at the data collected from the loan officer, your salary, your raise and criminal record, all those things, you predict whether the loan will be passed or not, right? The same way, right? So again, they will be given a data set, and then the data set is what I send you. They will be given a data set, and then that's it. And they will ask you as a data scientist, you should start working on this. It's like giving you a question paper, and now it is up to you to start working on it like a project, right? Okay, now we are going to start working. I hope we all have Jupyter Notebook installed. And last Sunday, I've gone through many of you who hasn't installed, and I hope everybody installed Jupyter Notebook. So just start your Jupyter Notebook if you can. Just go through Jupyter Notebook, and then it will open up in your browser. And then I'm going to start showing how about this project, how we are going to start working on this project. So just stay with me, and I'm going to go through each steps, and then you can try after the class. But if you have any question, and this is recorded, so you can always go back. So the first step is to, if you look at that, the first step, I'm going to open the notebook and then create a folder called workshop. How you're going to do that? You go here. When you open the Jupyter Notebook, you will see something like that, Jupyter, and there's a lot of folders. The first thing you need to do is create a folder. So just a folder. So that we can put all our program data set in one folder. So click the folder, and then you can just name it as, okay, let me create a folder. Okay, 1 second. Okay, create a new folder here called a workshop. I did something like lab here. The same thing, like you can see untitled folder, right? So you can just go, when you click it, it will say untitled folder. You click it here, and then you can just name it, or you can rename it. Let me see. Okay, here, go back. Where is it? Yeah. Okay, you can rename this. Okay, name. Okay, sorry. Can I rename it? I need to see what happened with my browser. Normally, you should be able to name the folder, but yeah, just otherwise keep it like untitled, or you can name it if you can. And then what you can do is you can upload the housing file, housing CSV. You download it, you can click open. So all you need to do is upload. After you are in the folder, you go here and housing and open. So your housing CSV, which is, and then click the upload. So your data set is here already here. Okay. So you have the data set, and now we are going to write the program. So first, I will verify why this, I'm not able to rename it, but just create a folder and upload the data set here. And then the next step is to create a program, which is new and Python 3.
I got to know how to upload, rename the folder.
Oh, how did you do that? Can you just share it?
You first of all go to the main folder file.
Okay.
Go where you have to change the name of the folder. Click on any of the folders.
Okay.
Straightly go up. No, not click it. The checkbox.
Okay. 1 second. Okay. Checkbox. Okay.
Now go straight up. There's an option called rename.
Ah, got it. I was like, where is it gone? Thank you. So we just say workshop, right? Thank you. What's your name?
Anushka.
Anushka. Good job. Yeah, you're
Thank you.
following. So what we did right now is you create a new folder first, and then call it as workshop, right? And once the workshop folder is up, you click it, and then you will see the workshop folder, and then upload the file housing.csv. So you can click this by opening the file and see the data, which is in a comma delimited. CSV is like comma delimited file. Okay. Now we are going to start writing a program, a model program here. Click new Python 3, and you can just click here, and it's going to start here. Okay. And you can rename the, untitled to, let's say this is a housing prediction. Like when I say Boston housing, right? Boston, a lot of home prediction, house price prediction, right? I just rename it, and I have this file. So all you see is a canvas for writing your program, and then you have different cells. So each cell you can start typing it, right? So now we are starting this. So the first step you did was we have opened a Jupyter notebook, create a folder, and then once you create the folder, and then we are going to upload the data set. That's also we did. So the next step is creating the program. So that's also we did. So the next step we are going to cover is we are going to use 5 different libraries. So NumPy, you will be hearing this a lot. NumPy and Pandas are a very, very useful library. I'm going to go over. Pandas is very capable, so it can do a lot of statistical methods. You don't need to write from scratch a lot of these things, and we are going to see that, so NumPy, and I gave some explanation here, and Pandas, and sklearn is a free machine learning library, and this is another machine learning library we have, that's also we are importing. And there's another one called Seaborn, which is of visualization. Visualization means creating, graphs and, just visualization library we are using Seaborn. And Matplotlib is also another library. So these are the main library we are going to use it. And I'm going to show you how we are going to incorporate these libraries into our program. So the first step we need to do is we need to have all this library imported into this program. So what do you do? So you put import and NumPy. NumPy is the library name. And then we just give an alias, right? That NP. Every time you don't need to, type NumPy. You just put a, alias name, like a nickname, like NP. You say PD is for Pandas. When we start using, from now onwards, we start using PD. So once you put it, you just click run, and that means there is no error, means it has been added to the program. So the import library is done. So all the functions in the library is available right now. That's the main thing. Okay. All right. So the first step is the first thing first is we imported the library. Anytime you start a program, you have to start putting those libraries. So the next step we are going to do is we are going to load the data. So we have we already uploaded the data, which is already there as a file, but we are uploading this data into the memory, right? So for example, we call it as this housing.csv. We are going to import this. We are using Panda. So PD, look at the PD. We are using Panda to upload that into the memory, reading from a CSV, like a comma delimited file. And then you see this is housing.csv is a file name. And because we don't have a header for the file, so we just say header is equal to none. Okay. And then you can run this. And then you see the data has been loaded. Then you can just see whether the data is loaded correctly. You can just say data.head. You can see all the data. So all the 0 is starting from 0 to 13. So we have 14 features. 0 to 12 are features, and the 13th is our prediction value, the house medium value, right? So you can say, okay, I want to see first 100. You can just do the look like 100, and then you can see all the 100 rows. And you can see only 2. If you want to see only 2, you can do that. So just wanted to make sure. Okay. So first step, you have imported the library, you have uploaded the data, and then we just see whether, oh, the data is uploaded or not. Okay. Are you all with me?
Yes.
Okay. All right. So now the next step we are going to do is, now we have the we loaded the data. So now is where we are going to, but think about this. You know what we have right now is we don't have a header, so we don't know exactly 0, 1, 2, 3. It's going to be hard, right? So how can we assign a column name for these columns, right? So what we need to do is this is a command, and based on this, you know, you need to have exactly 14, otherwise it's going to give an error. Okay. And these are the column names. You know, Python, each this is kind of a list where you put all those things into a column name, right? And then we are assigning the value. So let me go ahead and show how it's going to work. So first you put the column name into a list, and then you are assigning the list to, this is the data which is loaded, the memory, you know, into the memory. That data is the, so data.columns, it has a property called columns, and you are passing the value column names, right? So now, okay, there's something wrong. Okay, so because this, when I copy into PowerPoint, it just take the single quotes, and so let me take this, because it should be single quote, that's why. Okay. So if you have that problem, you know, make sure that you have single quote here. And now when you say data.head, what is going to show up, right? See that it has all column names, right? 1, 2, 3, up to 14. And this is our target, and these are all the features, right? Just imagine. So we have the data, the library loaded. We have the data has been loaded. We have the column name assigned. Okay, what is next? That is the main work we are going to do. It's called the data exploration, right? So now, so when you say data, so we want to see the mean, medium. I just talked to you about, you know, how we can understand the data a little bit more, or why mean, and standard deviation comes into play. When I say data, so data is the one which is loaded. So that is why we call it as data. Let's say if I put, instead of data, I put data 1 or input data, you have to use the same name. Okay. You can try that. So we got a lot of information, the statistical information about the data, whether the data looks good. So like I said, the more the standard deviation is not good, because data is not really data closer to, like we cover that, right? The standard deviation, what is going to be the effect of the data. Just like I told you, like 100 books, you are eliminating 90 books or only keeping the 10 books, right? So all these feature, which feature you got to eliminate. And this is going to show, looking at a data scientist can look at the data. Oh, this looks good, or in this example, room may be a good example. But if you look at some of them, 91, this is not a good feature. Look, as soon as you see, the first thing you see, okay, whether this is good or this is good. So the standard deviation is going to give you how your data is skewed, and then the quality of the data. So for example, when you're learning for the exam, you got some books which is not at all good, and it's going to show in your result, right? When your exam, you may not be scored well because whatever you learned is not in the exam, right? So the quality of the data is very important. That's where we started looking at, right? So we have 506 records, rows, and for each column we have, right? And what is the mean of that crime rate, or the room? This is the mean. The 6 rooms are the mean, right? The standard deviation. What is it deviated from the average, right? And what is the minimum? The smallest number is 3 room, and then the highest is 8. And how the data has been across the the 506 records, how this has been distributed, right? So this gives you a very good understanding of the data exploration. So this is very important. I think I'm going a little fast. My daughter said I'm going a little fast, so I'm going to slow down. So do you guys understand? Sorry, I'm going a little fast. Okay, going through one more time. So first we import the library. You know why libraries are important? Is just like when you're studying, you take book from library, right? So like that. So there are functions available in the library which will be useful for loading the data, analyzing the data. All those things are part of the library. So that is why we first import the library. And the second thing is you upload the data into a memory using the pandas. So you can also use from NumPy also, but we are using pandas for in this example. Okay. And these are the columns we have. We assign the columns, and then we look at the data. Yeah.
Venkatesh. So everything Panda and NumPy, everything has the same function names, or?
No, the Panda and NumPy has its own functions, different functions.
Okay,
but in the end, it is going to give you what you need. But it's like you got two when you for the exam, you bought 2 books for SAT. There's a lot of books available. For entrance, you have a lot of books available, but you have these 2 different books have different syllabus. But in the end, it will let you load the data. NumPy also can load the data. It can sort it. It can also do, but it has different functions available. So read.csv may not be the function for NumPy for uploading it. But that's basically it is. The pandas, when you upload it, once you upload the data, the pandas, they call it as data. This is called a data frame. So once you get that data.
So data is an object. So you're storing everything there. And see, these are the data head, data describe. These are the different functions available in pandas, isn't it?
Exactly. Yes.
Okay.
Yeah. So data.head is a function available for the method available for the data frame, which is when you read the CSV, it gives you a data frame. But when you do a NumPy, you will get a list as an output. right? But you can just convert that. With the list, it can do all those different functions based on the list. Panda has its own data frame, but you can always convert that into a list. But I don't want it to confuse. That's why I just didn't talk much about it.
Yeah, actually, Pandas is more faster and has more functions. So
Exactly.
Pandas is also more latest. Before Pandas, I think most of them were using NumPy.
Exactly, yeah. But if you look at a lot of examples you wanted to learn, you see a lot of places they use NumPy because it's been created like little bit long time ago. So other thing you can do is you look at the pandas library. You can just search it in the the pandas library, and you can pandas, right? It's like pandas. See, pandas library. So there's a this is all they started talking about pandas and what all the the user guides, getting started. There's a lot of methods. So you have a lot documentation for that. You can go into web and get started, and these are the user guides. See, introduction to data structure. That's all totally a different topic we need to learn, but sometime we will work on it. So in pandas, you look at that, selecting the data, indexing the data. These are all the functions available. So you see the the panda pd.date range. You can find the date range. When you are exploring the data, you want to remove some of the date which is like 18th century date or by mistake. All those things you can do. And then working with text data, how you do the text data series, you can do it. There's a lot of like chart with how you can create chart. So there's a lot of things available in pandas library. So you can go through this cookbook. There's a lot of things available in pandas. So 10 minutes into pandas, you look at that. Import pandas and how you are uploading, what all the series you can create, different series of data. You can try out. That's a good way to get familiarized with pandas. You just go through the pandas library. It's a free open source. We can go ahead and explore how viewing the data. See, it says viewing the data. How do you do the selection of data? So a lot of things are available. Like how do you find the missing data? So this is basically help you for data exploration and understanding the data, right? The same thing with NumPy. If you go to click a search on NumPy, you will see lots of functions available in the library, right? Yeah. Okay. Can you move forward? Hope you understood that. Give me a thumbs up.
Yeah, so the pandas and the NumPy, these all are huge libraries. There are a lot of comments and functions there, but here we are just going through only the basic ones. So it gives you a feeling of how to use all those functions.
Exactly. Yeah.
And how much you know, the more the functions you know, more how details you know, that much master you are.
Yeah. So you don't need to master from the beginning.
I don't need
You
to.
can always start with small things, and then you see, okay, there is a need for you to sort it, or there is a need for you to do some categorical analysis. You can just go to Google and type it, and then you will find it. It's pretty easy.
Yeah, don't get overwhelmed with all the lot of library functions available.
Yeah.
Just learn slowly, and as and when you need something. So it is better to go through some coding like this and samples, then you learn more of this.
Especially for interview purpose, it's good to understand all these panda libraries functions. At least it's been used a lot. Like I will say every day, just take 5 panda function, just try yourself, and then make it familiarize. And that way you can do with NumPy also. So once you kind of do like 5 functions a day, just imagine like a week, you will be the master of it. So, and then you keep refreshing the same thing over again. So, because it's going to be useful as a data scientist life, pandas is going to be useful every day. So that's, you can learn. So now we did library, we did Panda to load the data, and we did some data exploration, seeing that, oh, how this data is looking good. Okay, the next thing is we are going to do a little bit of visualization plots to see how this data is plotted. So this is going to take a little bit, almost like 45 seconds, because we have 14 features, and this graph is going to show 14 multiplied by 14. That kind of combination, it's going to show for each column how this data is visually available. So look at that, right? So it's going to be so hard to see, but I will try to show you here. So how the data is distributed with the criminal crime rate, whether this crime rate really matters for this tax, or this crime rate really matters for room number. All those things you can look at that, how the correlation happened, right? That is what exactly a data analyst should do. So look at this is our target, right? So our main thing is whether the target is really correlated with any of this, looking at this data, how this is, if you look at the room, it's kind of linear, is the data is kind of linear, right? There is a lot of, here looking at that, there is a lot of cluster forming into a particular format. But here it's all over the place, right? Here it's all over the place. But look at the median itself, that this is not a linear, because this is like coming down. And but looking at the price distribution itself is a good distribution, looking at that, because this is the price versus price. So you don't need to look at that, but this will give you a data, how this data has been. But looking at this, you can see the room may be a good fit for predicting it, but the other things are also there. But when you teach, for example, I'll give you an example. The more you study, you say, oh, okay, I will be more confident for the exam. But if you study more than what you need for the exam, and you get an exam question with multiple choice question, you will get confused, right? So that's for overfitting. Like over learning can also lead to a problem, right? So if there are some data which is going to give a wrong result, and you think that, okay, I'm going to, anyway, out of 900 books, I'm going to study all 100 books, which is good, right? And the parents will say, oh yeah, you're doing good, you got all the books covered, you're good for the exam. But you may not be scoring good in exam, because you can, when you get a question, it is not relevant, but you start writing something which is not even they're asking for, the examiner is going to say, oh, what is he talking about? Even I don't know about this, right? So that's why we are kind of removing a lot of noise, which is not required, and it may not be able to predict the right answer, right? That's where you call it as overfitting, right? Narsi, you want to just say a couple of sentences on the overfitting? The more feature, the more noise, it's not good for prediction, right, Narsi? He may be on mute. Okay, so this is what the
I'm sorry, I was speaking on mute.
Yeah.
So yeah, overfitting, it's as Venkatesh has explained, if you have too many variables and then too much to derive from the variables, it gets confused, and then you probably want to remove some of these variables that will not help you in prediction. So this visualization will help you to identify. By looking at the data, you won't be able to interpret what the data point is and how it is fitting with respect to the other data points, right? But visualization will give you a clear picture where they stand on a scale, and then helps you to identify any overfitting or underfitting. There are underfitting concepts also. So you can take those out and then use the variables or features that you think will help in the predicting the end, endpoint. It could be a price here, or it could be a score, credit score, or it could be a purchase power, or things like that.
Exactly. Yeah. Thank you, Darcy. So now we have gone through a visualization plot, and we are using the SNS library. So the plot, I told you that SNS is another library with a function called pair plot, and it will tell you, oh, this is the data, and it knows what to do, how to create a graph for you. So you can just go through all the graphs and find out, okay, looking at the visualization, oh, maybe a room is a good predictive, very good feature. I can use it for my program, right? So once the plot is drawn, I can also do a plot for, because this is like too many, right? So now I am going to drill down to, okay, I see there are two columns are really kind of looking good. I just wanted to do a little bit more on that. So I can do something like only for these two columns instead of all the 14, you can just do like this. So this is going to draw how for this, see the room, how the data is distributed. Because this data is not good, because all those data is skewed. This is called skewing to one place, which is not good. Like, here everything is on one side, which is not going to be helpful for predicting. But if the data is all over the place, or like, there's a pattern evenly distributed, for example, that in the second quadrant I am talking about, evenly distributed, which is a good thing, where you can get some, these are the good feature. You can drill down to which one of interest, so you can do that. Okay. So once you have done that, and then the next thing is correlation. So the correlation is, while we are selecting the the data, you want to see how these data is correlated between each other. It's very important to understand the correlation matrix. So this is called a correlation matrix. So the crime rate is correlated with crime rate because it's 1-to-1, because each one is related to crime rate. But you look at that, all of them in a diagonally, you see one, because the crime to crime, ZN to ZN, indus to indus, right? But if you look at the correlation, otherwise like crime rate related to zone, crime rate related to rooms, see that coefficient, the correlation. So you can understand what the correlation is. So the correlation will give you an understanding. For example, this is our prediction, right? The more that correlation near to 1 is a good correlation. For example, here the price, this is a target, this is our interest, but I'm looking at the room, it is near, right? 0.69, it is near to 1. That 0.4 is little away. Even if minus is fine, near to 1 is more important. 0.17 is not good. 0.4 is not good, but out of that, near to 1 is 0.69, which is a good one, right? So this is how you can select the feature looking at the correlation. So we looked at the mean, medium, mean, standard deviation, and then we are kind of trying to find the correlation. So that is the next step. Keep it in your mind. And once you find the correlation, so let me go back to my PowerPoint slide. So now, okay, sorry. The correlation, I'm going to show the correlation. Okay, so correlation refers to a statistical relationship between the two entities. So here the entities is index versus crime rate, or crime rate versus room. It's a matrix, right? The value near to 1 is a more relationship between the columns. So, but one, if you're looking at this to the same price to price is 1, which is we cannot take it because this is exactly related, but you are kind of finding a relation to other features, and out of this, which one is kind of near? So here, looking at the room is 0.74, right? So this is a pretty good one, right? So that's what we are trying to get through the correlation matrix, and then find out which one is good. So, and also this correlation we can do in a heat map. So heat map is looking at this color. We can say the more heat is like this color, or we can just change the color from heat. The too much heat is red, and then you can come down to blue. You can set it up all. And I can show you one of the example here in this plot, how we can plot this. And let me go into that. And this is a plot figure. Fixed size is the size, the whole, the chart size. And then we are creating a SNS is a library. I already said SNS is a Seaborn library. Sorry, SNS is a Seaborn library. See that. And Seaborn library has a heat map as a function. And we want to see how this heat map look like. And like, look at, instead of looking at this value, you want to see how the heat map is looking at that. So the one near to 1 is the one we are looking at. So this is, we are looking at the medieval price range, that the last column is what we are looking at, or the last column or the last row, right? So in this, more correlation happen at the room 0.7, right? That's what that you can see. You can change the color scheme from red to blue, so that the more red is something which we can identify, right? So instead of the whole thing, we can also do only the couple of columns. And my interest of columns, I wanted to see, okay, out of these columns, I wanted to see how this is for the crime rate, the zone, index, room, or medieval. What is the best one? So you can see a little bit more in detail. So this 0.7 is looking great, right? That's the correlation. Okay. So now we have the data, everything is ready to go. Now we are going to start the linear regression. So what it is, say the correlation value is ranging from -1 to +1. If it is 0, then there is no relationship. Don't even take that, that column. But if it is close to +1 or -1, then take that. So that's what it is, right? So in this case, I was talking about 0.7 is the first bet for me, right? And the second bet is this -46. You can take that. You can consider that. 0.41 is also good, but 0.15 is not at all good, and 0.14 another one is not good. So that means this column is not even correlated with the price, so don't even take it, right? But here in our case, a room is the most correlated with the price. Then we can take the room as the one, right? So that's what.
So Venkatesh, when you say correlated, that means if it is closer to 1, that plays a major role in affecting the value of the outcome, isn't it?
Exactly. Yes. Yeah.
Okay.
So for example, when you are going to buy a house, the first thing you are looking at salary, right? And then they also look at whether you are if you are a bank who is looking at giving a loan. The first thing is, there are a couple of things. Like one is a salary, and then the second one is something related to that person's whether he has hair or not, right? But bank will look at the salary as the most correlated with the whether he has the purchase power or not. But whether he has hair or whether he is tall or short, it doesn't matter, right? So those correlation will be mostly near to 0, but salary will be more near to 1. Sorry, so more related to the one which I was talking about, the correlation which is near to 1 is more related, right? That's
another example is like you have a salary and you also have another data point called income to debt ratio, right? So if you look at income to debt ratio, he's making good money, but he has a lot of debt too. Even though the salary is like 200,000, but he has income to debt ratio is very high. That makes lender to think that, he has got too much debt. So maybe I want to, I'm risking, so I cannot give him the good interest rate. Maybe I have to increase his interest rate, right? So as you've seen the difference, like salary just gave you one particular angle for the debt element, but when you have the income to debt ratio, when you have these two features, probably income to debt ratio is more valuable data point.
Exactly. Yeah, that's a real good example. So that's very important to understand how you are. So the correlation is the most important. Right? So first, in a data scientist, they always talk about project. Hey, what was the correlation? Which column you are going to take, right? For this model. So the first thing they said, okay, did you see the data exploratory analysis? Did you see which feature makes more sense? And they will say, oh, what is the correlation, right? So now, once we found out a room is a correlation in our project. Now we are going to go with, so once we have the correlation, next one is what we are going to start taking the data and we are going to start teaching the model. So we are using linear regression. So what we are going to do is we are going to take because we only want to take the room as because we are eliminating all others. So we are taking the room only value and we are assigning it to another variable called x, which is a data. We are giving two information to the model. One is x and y. The other one is y. X is basically the data we are going to be using to predict it, and y is the data which we are going to predict it. So we are putting to x. Why we are reshaping is the thing is we have a room in, so sometimes we have the data in so many different values, but we just wanted to standardize between -1 and 1. So that is what you're kind of trying to reshape the value, right? But I will cover a little bit more in detail later. Then now we are getting the y value, right? So the y value is this. So we have the room and medium price. This is this is what we are trying to predict it, the price. And this is what we are trying to teach the system. And, this is a value which is dependable. This price is dependent, right? So we have x and y. So if I say x, what will happen? X is going to show all the room values, right? And then if you put y, you can just run it and see. This is a array of y, all the value for y, right? We have 506 rows, right? Now the next step is we are going to create a algorithm which is going to be we are creating a linear regression. And I will talk about linear regression more in detail, but for our project, I just wanted to show how the linear regression works. So we are taking the skill, sklearn is another library I mentioned this, and we are importing a linear regression model here. So we are creating a model equal to linear regression, okay? And then once see that, this is exactly we are teaching the model. So we have the model here. This model is empty now, right? So now we are fitting the model with A, if X is the value, then Y is the value, Y is the prediction, right? So you fit it, and now the model is ready. You have created a model, right? And now we need to say how efficient this model is, right? That is where you see the coefficient of the model. What the coefficient of the model will tell you how it can predict, how is it, the performance is, which we have a 1.910 is a pretty good the coefficient, and I will talk about a little bit more in coefficient, but I don't want it to confuse you now. This is where you are seeing whether how the model is performing, right? And then the intercept model intercept, and then and also I wanted to plot how this model has been performed, and I'm going to show. See, the average number of rooms per dwelling and the price. Look at that. This is a linear regression problem. So this line, you see the blue line is called the best fit line. So what the best fit line is, all the other dots, right, on top and the medium, what is the deviation from the, from the line, from the best fit line. If it is too far, which is bad. But here, look at that. Most of this data is coming near to this. And now, which will tell you whether you say, I have 7.5 rooms and I can predict the price, it's around 30, right? I can look at the line and see, okay, it should be around the 30, between 25 and 35, I can predict it, right? But the other ones which are so far away, those are outliers, because those data, we should look at it a little bit detail and why it is too far away. And we can look at it, maybe some other features are affecting this, so we can just iterate that. So we have a model we created, and now it is ready to use. We can start predicting it. So in this class, I want to stop at that, because I don't want to give too much, and you will confuse yourself. But so far, hopefully you understood all the concept. I'm going to go back. Can you scroll up the command? I'm going to post this this file in the Google Classroom. Karun, is that good? Is this one you're looking at? Sorry, I didn't see the chat. I think you're good, right?
So Venkatesh, what was the second ranked feature that we came across? I remember you ranked them, right?
Yes.
In your PowerPoint. Can we go back to that quickly?
1 second, the PowerPoint has that feature. Okay.
Yeah.
The second rank is this.
Yeah, second rank is what, PT ratio, right?
Yeah.
So, I mean, I'm just talking here. Let's say if you take the PT ratio as your best feature, then if you run the linear regression, then when you plot it, you will really see how the points are very scattered. You will see more outliers and how the data points are more scattered, and then you will understand why that is not a good feature to predict. So you can even, try to build a model using the second feature, and then you can compare both the graphs and then understand why you choose the rooms versus PT ratio, right? So that is also done by modelers during the model development. They take the second one, also try to see what they chose is correct, and then it's a good.
See that PT ratio.
See how bad it is. Like so many within that range, you have only few data elements. Rest are all like scattered very high and then very low. Compared to the previous graph what you have seen, if you use this feature and then try to predict, your prediction won't be very good. Whereas the rooms is, if you use that, your prediction will come very close and very realistic. So exactly. I just wanted to point out that, you are going back to the second best feature that you thought, and then you plot it, and then you confirm that, okay, this is not what I want to use. I want to use the room. So during the data exploration, the data scientist will plot multiple things and then go back to the drawing board and say, this is a feature I'm going to use. And that's how they justify why that feature is best.
Exactly.
So I just want to bring that up. That's all.
Yeah. As a data scientist, that is one of the things. Okay, once you got the plot, you just update into your documentation that because of this, I selected this, and then finally you'll have a meeting, and then you will start working on the model. So before getting the model, these things are very important. So far what we learned, I just wanted to conclude. It's getting interesting, right? Don't think that it's the more you work on it, similar way we will learn other classification problems and prediction problems. So we will discuss it, and we will all work together, and then you can try different things, right? So just to conclude, today we learned about supervised learning, and our main focus was continuous target variable, because the price is a continuous variable. And then we've been given a data set, and then what we did, we also learned the statistical method to explore the data, mean, medium, mode, or mean, standard deviation, percentile. And then we started working on Boston house prices with regression. That's what we did it today. We've been given a data set, and then what we did, we created a Jupyter notebook project, and then we go through. We kind of learn little bit about the library in a very high level. So we are using only 5 libraries. In more classes, we are going to. I'll give you some homework using pandas. Do this, do that. That will make you familiarize. And now we load the data into a Panda data frame, and then we started assigning the column names, and then we looked at the describe, looking at media mode, and then we look at plotting the data, how data is distributed. This is what we are doing, distribution of data. And then we look at little bit more detail on the 2 features, and then we started looking at the correlation, and we looked at the heat map, and then we finally found which feature you want to use it. We initially looked at room, and then we looked at the PT ratio, and find how the model's efficiency is. The more you teach with the right data, the more result you will get. So give me a thumbs up if you all follow, and if you need any question, I will set up a Thursday an hour and go over with all the details. Whoever missed the first and the previous classes, I can just catch it up. But from this point onwards, don't miss a class, because if you go to other classification problems, you won't be able to understand if you don't follow this. So, but other than, do you have any question for me? Mani, you want to say something, or Narsi?
Yeah, I'll say thanks, Venkatesh, and very informative. I also learned a lot. I'm not a data science person, by the way. Now, so these are the type of results that we are using for the daily research. Everywhere it's used. Okay, for example, if somebody is predicting the election results, okay, they'll compare like different factors into, okay, or the urban area, non-urban, rich, poor, age-wise. That's all calculated based on this.
Education.
Yeah, education.
Mhm.
Yeah, and so from that, okay, where they are voting towards. Those type of this research are the ones. Yeah.
Mask mandate. They are looking at, the government will see whether your mask is required, the number of hospitalization model, things like that. Yeah.
And the COVID medicine, when the COVID vaccines came, that they used this and for their trials also. So they gave the real COVID vaccine and also a passive, it's like just a plain water that a group of people they give and how they react to those things. They use this type
Yeah,
of things.
the vaccine will not be approved by the the authority if you don't show all these graphs and prediction, and there's a lot of things they need to do to pass any medicine in the market, right? So yeah.
Everything you're learning here, it's all used in real life. Okay, so that is the best part of this. It's all new technologies that we are using. And thanks, Narsi. Narsi is an expert in data science. He's working in that field also. Yeah.
Yeah, Venkatesh, session is very, very useful. I mean, I don't use a lot of these on a day-to-day basis because I'm managing the projects. But, the data scientists and data engineers and then application engineers who are working in the team, especially data scientists, they use this, on an average for us to build a model and then deploy to production, usually, from the data exploration to building the model, testing and validation, integrating with application, usually takes anywhere between 3 to 6 months, depends on how many elements that we are using. We are using a product called Data Robot to build our models. Whatever you guys have seen, you're using the Python, custom code is being written here, but there are lots of COTS products and then lots of automated way of doing these things are there. So in the industry, people will be using these COTS products. Even with the COTS products, building the model, cleansing the data, munging the data, all these things takes time. Once you build the first model, then once you deploy, you will keep looking for additional data sources and additional data elements to enhance the model, because the models perform optimum at up to certain point. After that, model performance degrades, then you have to go back by the data that is coming in real time. You have to go back, either refresh the data model, or you have to rebuild the model. So some of those concepts probably Venkatesh will be touching upon at later sessions.
Yeah. And also Uma is already here. So he has a good experience on the AWS SageMaker, which is another machine learning. And he's going to take one class on the SageMaker side. And I'm also kind of working on a project. So I will share some of the project, high level scope, and then at least you understand these kind of problems will happen. But when you look at these coding, you think that, oh, this is not cool and things like that. But when you make these models, when you start implementing in your artificial intelligence, that is where you will see all the work you did, the underlying work is going to show the result, right? So let's like an underwater robot and how it can detect the mine. You write all these models and then you just put it into the system and then create an app, incorporate that into an artificial intelligence app. But there's a lot of hard work behind the scene, like creating the model, but don't think that it is it is not cool. But it's pretty cool where you see the underlying technology or underlying methods are used to build it, right? So just understand that this is a real cool thing. And data scientists are the number two, one of the main number one or number two jobs in the market. And a lot of these insurance companies are the one, energy companies are the ones started using it, but then it went to robotics, manufacturing, healthcare, everywhere. This has been used every day. New algorithms are being developed, even without knowing. When you're typing something in your phone, or a camera taking a picture. There's all these models are used behind the scene without you knowing it. So just be aware, and this is going to be a very good opportunity for you to learn the basics and be a data scientist and make a career out of it, right? So thank you so much. Uma, you have anything to share? Like one of the class you will be sharing the SageMaker, right?
Yeah, I will plan for demo on the setup of that. Yeah.
SageMaker, yeah. Thank you, Uma, and thank you everyone for joining today's class, and hope this is a great initiative where you learn. And if you want to teach somebody else, that is great, your friends, and then you will learn more. So thank you so much for today, and have a good day.